Hello. What am I working on today? I am delivering value. Delivering value. Specifically right now, there's some variables that don't show up in the debugger, in the LLVM backend, and that may have just been very easy to fix. So we're going to see, come on, Visual Studio. Oh, Visual Studio. All right, so what if I just breakpoint here? What is last turn time? Particles time passage rate. That's great. Do we get the constant? Inventory extra spins. That's great. Let's go to another file. That's a procedure. I mean, this is just working better. So that's good. That was very easy. That is enough to deliver a value to the people. That was really not a good bug for me to let go as long as it was, if I'm being honest. But I can only do so much. There we go. You wonder what I do with the Twitch bucks. Well, I do buy a little bit of equipment once in a while. I mean, I bought the fabulous camera that we are using with the Twitch bucks. I spent an advertising budget so I could get massive raids of 5 people. That's pretty good. I don't know. I bought the eye tracker that we used for a while with Twitch bucks. Did I watch the GDC Awards? No, I did not. Did I manage to solve the link or can't find the object file we just created problem? Yes. The solution was do not use fopen on Windows. Seems like every GDC talk is about social justice now. Well, if I were to be cynical, I would say that if you didn't have much substantial and concrete to say about how to make games, then you could try to fill that in with other subject matters. Okay, well that one was really easy. I had expected that to be harder. Yeah, I mean, back when GDC was actually a real event, I really had stopped going for years, and then I went one year just to make sure I wasn't missing anything, and I really wasn't missing anything. It's pretty sad because I used to do a lot at the GDC. There was one GDC where I did 5 different sessions, either being on a panel or running a session or, giving a speech or whatever. It was a lot. It was a lot. Do I have any talks lined up? I am doing a pre-recorded talk for a conference in China that will be translated into Chinese. Apart from that, I don't know yet. You'll get the English version, not of this specific recording. This one I'm recording just for them. But it's a half an hour speech, so I might do an expanded version that's different later on. So I wonder if I should do this compiler performance improvement thing that I would like to do. Seems like I should. Let me think about this. There's a hash table. A lot of things get put in it. And I suspect that most of the things that get put in it don't need to be put in it, which is very good. As we work toward making the compiler faster, it'll be good to just not use those resources. The problem is the primary way that I can think of saying, hey, this thing doesn't need to be in that hash table, is by like the type of the syntax tree node. And sort of the conceptual problem I have is, how am I going to know if this ever breaks over time? Like, even if I pick, right, okay, even if I pick right now, like, oh, these things don't need to be in the hash table, the problem I'm having is that I think if that breaks, it's a soft break where it causes us to copy more data inside the compiler, but it doesn't necessarily cause anything to fail. And that's actually bad. Because then we won't notice and fix the problem. So I'm trying to think about like how can I ensure, okay, one way of ensuring it is to have some super debug mode where we assert that things didn't need to be in there. Have I given any consideration to writing my own linker? That question just annoys the shit out of me. Like, the whole point of this is we don't link. The whole point of this is to throw away old stupid tool chains, right? Now we have to link because, you know, we need to let you operate with libraries that want to link, but that you shouldn't then, like, the fact that you're forced to have this thing lay around in order to do old stuff shouldn't make you think of that thing as being a thing that you should have around in the future if you could help it, right? We probably could reduce our link time a little bit by combining all these frickin' stupid WYs libraries into one, like they actually should have been in the first place. Like, all of those should be one library. Actually, more than that, right? Because this AK bridge as well. Oh, I talk about people ask this all the time. That's the only reason I'm annoyed about it, is because people keep asking it. And the reason I'm annoyed is because it represents, like, the fact that so many people ask it, like, as a mass shows, like, it just represents that mentally people are in some space that I am totally not in and don't think is good, right? And that's why I'm bothered by it. It doesn't mean any particular person has an incorrect outlook or something, but just that, like, when you average over all these people, it's not where I would like it to be. But of course, we knew that because that's why software is the way it is today to begin with. Why is kernel 32.lib specified twice? Probably the compiler emits it once, and then probably because it's in libraries, it gets added again, and then we don't filter it. So, you know, we could probably do that at some point. So what do I do? So the deal is I'm using this hash table to know whether two things point at the same thing without destructively modifying the syntax tree nodes, etc. If I wanted to use a flag on the syntax tree nodes to say, no, that doesn't actually help. It doesn't help. Anyway, I think what I'm going to do is I'm just going to start doing a little bit of programming to observe the data. Like, I want to know what things in this hash table actually get used and what don't. And then again, the second conceptual problem is that doesn't necessarily tell me for sure that those are the only things that could be used, right? But we're going to give it a try. So in message exporter, when we look a thing up, I mean, yeah, so get exported looks things up in the frickin' hash table, right? Does anyone else know? Okay. So if we're in debug, then we do a thing. What is that thing? Well, this is a different histogram. Where is this stored? What? Hash table key value. I see. I see. Okay. We're going to have okay, so we're going to have an array of num_ast types. And we're going to say S32 I'm just going to return the number of hits. Like we might return hits for one particular node a lot of times. But anyway, I'm probably going to want to add a lot more data. But for now, we're just going to say S32 num get exported hits. And there's one for each ast type. Okay, if value num get exported hits value type plus because we're in C++. Okay. I think we have to initialize this. Okay, so we're going to clear that, and then down at this histogram, we're going to say get exported hits by type. I and this. Okay. And we need to be in debug build to do that at all. Illegal index. Okay. Debug on the SOCO ban. Okay. So I actually want to sum these up and get the total. Anyway, so these should, actually, I don't know. Anyway, so this is like, how many times do we have to poll the table? And most of the times it's on the first hit, 0, right? Sometimes 1, sometimes 2, but sometimes we have to go like 15, right? And that's why I would like to reduce load on the table. We could reduce the load factor and all that stuff, but anyway. So I could do the hits and then the number of ads, right? And then we could see by node type who's getting added a lot that isn't getting hit. Right? Let's do that. Oh, we have an extra debug. Interesting. Anyway, shows you how often I use that. If def debug, like that. Okay. So we can see, I mean, honestly, this doesn't look very good to me. Okay, because the problem is, so in theory, if there are adds but no hits, we could take those things out of the hash table. Okay. However, there are things with a lot of adds, not that many hits, but we don't know which ones they are, so we need to add them all, for example. I bet this is declaration or something. So we could do some sub-queries on these. Like maybe import links can't ever get hit. Actually, I doubt that. No, I know that's not true. Anyway, so there's a bunch of smaller numbers over here that we could get rid of these from the hash table, but when there's like 300,000, 400,000, 500,000, these smaller numbers are not going to add up to enough to really move the needle. So the question is, what's going on? Are some of these not necessary? Are some of these hits fictitious? Can we get away with not doing a bunch of them? You think I forgot to init the table? I did forget to init the table. So I think we got lucky and it was full of zeros, but we will rerun it. I mean, you never know, but I didn't see any actual garbage numbers. Yeah. Same result. Let's look at what some of these are. So that are in here a lot. 3 and 5, for example. Identifier. Five is binary operator. Really? Why is binary operator in there so much? I mean, there are lots of binary operators in a program, but I mean, why are we hitting it in the table so much. One thing I could also break out from this table, there's a difference between when things are queued for their own compilation unit or not. And that is not a thing that we're selecting for in this data. So I could break these numbers down again by queued or not queued for both. You could just get super combinatoric about it. Although, maybe we only care about that on the hits, not the ads. Okay, 25 is a declaration. That is no surprise that we look at declarations a lot. Yeah, these really, the ones that we can save right now are not that helpful. So the identifiers, why would there be so many identifiers? I'm actually not sure about that. That is a question. If we could avoid adding most identifiers, like if we knew the difference between identifiers that could be looked up and identifiers that can't, then that would be helpful. Same with binary operator. I really am not sure. I guess if you have an operator overload procedure call, it points at the operator. But there might be ways we can alleviate that. $19 doesn't have very many things, lambda, right? So we look those up a ton, like a huge ton. Probably stack trace. No, I don't know. Procedure calls, pointing at the target, at the resolved target. It's interesting that we have almost 10,000 functions in our program. I don't love this. I don't love these numbers. I had hoped to see better numbers than this just off the bat. I had hoped to see numbers where it's like, oh, you can get rid of most of these. And then just try to make sure, the hard part would be making sure that we don't introduce a mistake later or even now, right? Just download better numbers. I wish. On the other hand, these numbers are promising in the sense that, like, for some of these big ones, so like for this 300,000, it's like, okay, you don't actually need most of these probably. We only need less than or equal to 30,000 of them. Maybe a lot less because we might be looking up the same identifiers multiple times. It's hard to say. Even in cases here where declarations are referenced a lot. I don't know if that means all the declarations are referenced or if some subset of them is referenced way more. Now the question is, how much do I have to reduce the amount of stuff in this hash table for me to think this is worth it? And I think the answer is if I can cut it down to 1/4 of its current size, I will not be super happy with. But I'll feel kind of okay with. We need to like print out our Weissman score at the bottom as well. It's not Weissman score yet because we don't know what we're trying to reduce, but okay, so I want to change the way this is stored. What do I want to call this? S32 num hits queued, S32 num hits unqueued, and S32 num exported. All right. So we're going to have export records, and that's going to break literally everything. We can get rid of this now. Okay. Okay. Okay, so here, Okay. Oh boy, look at the mistake. Look at the mistake. Uses undefined struct. Oh, because we didn't do that. Kind of need to do that. Okay. Maybe this wasn't the best way to draw this, but anyway. Interesting. Okay. This is really weird. Okay, I was hoping for better numbers again. So I was hoping to see some stuff where it's like, oh yeah, all the ones that are exported are queued, so we can tell which ones they are. But that's not actually what the difference was for almost any of these, except here. But even here, there's 2 that weren't. And if there are 2 that weren't, that sucks. And that doesn't matter anyway, because there's only 10,000. That's lambdas. There's only 10,000 of them. We don't care about it. We're looking for 100,000s. Bruh. These numbers is so bad. Okay, well, next we're gonna do it old school. So what we're gonna do is we're gonna say, well, this is the highest number. 24 is the highest number. Forget about it. So that was ident, right? Ident. So we're just gonna see, like, literally, I'm just gonna break in the debugger when we get a hit on ident, and I'm going to see if I see some pattern about where that comes from. Okay. We are exporting an ident. For arguments because they're in the procedure. Yeah. So that's just in the data structure that we fill out to tell you about calling the procedure, and rather than okay, but that does tell us what identifier this is. It's like, okay, an identifier that's on a declaration can be pointed to by other things. Like that's the head identifier of a declaration. Okay, this is a different place. Here, we are doing wait, we're in the same place, but it's different. Oh, wow. Okay. So this is the word message, and it's like, how, probably this one. I don't know why that is considered to be the same identifier as something else. The problem is I should just look for this one thing, for this ident, as where it gets exported in the code. Right? I want to know, so we're matching this identifier. Like I could imagine something crazy, like we're accidentally exporting this whole thing twice. That would be great to find out. But like, as far as I know, there shouldn't really be more than one reference on this expression. Oh, no, because it's in arguments unsorted as well as arguments sorted. Okay, that's interesting, okay? This is... See, my analysis so far has been trying to break things down by type of the node. But this is a thing that affects all node types, and has nothing to do with the node type. Okay, so the two times, so we have identifiers in declarations. We have arguments unsorted, arguments sorted. Now it's worth noting, we could actually do this one manually. Like for the arguments sorted, we could just do a tiny little n squared thing where we match them against the unsorted, and if we see that, then we go. That said, it's not that simple because there could be like casts on the outside pointing at the same node on the inside, I believe. So that approach is not good. But also, I believe it's the case that these arguments unsorted they don't need to stick around, actually. Like, we could remove them afterward. Problem is, with this hash table, removing is not necessarily very good. But we could switch to a different hash table where removing is better, or maybe removing, if we remove enough things, is like pretty good. Anyway, this could start getting us the kind of numbers that we want, because if there's 10,000 functions, I mean, some functions have a lot of arguments. I would bet that the number of things going into the hash table is probably at least 30 or 40,000 just from this one spot. That doesn't make that big of a dent in the grand scheme of things, but it's okay. Export declaration info. You know what? Maybe I just say F it and just let this hash table be as big as it is for right now. That's kind of how I'm feeling right now. Same thing. Arguments unsorted, arguments sorted. Why is this in a declaration, though? Oh, a type instantiation. Well, I don't know what to do. I don't know if I want to keep working on this or just think about it more later. I definitely have a little bit more understanding, but I had hoped that this would be easier. One thing that we could have, okay, instead of breaking down by queued or unqueued, because that doesn't seem useful, we could break down by same compilation unit or other compilation unit, right? Because if that was useful, we could reset a particular table after every compilation unit, which actually might be a little bit slow, but we could reset at every n compilation units to amortize. Let's find out about that. In metrics, queued v unqueued was not very actionable. Just deleted a 5-year-old user folder. Yep. Did I figure out the file IO? Yes, we figured out the file IO. That is fixed. Okay, so I want, instead of queued versus unqueued, I want to know same compilation unit versus different compilation unit. Problem is, I guess it's maybe not that hard. Okay. Other cool. Okay. Same coup, other coup. Export record. Very good. Use open, read, write, close. No, don't even use those. Use the Windows functions if you're on Windows. The open, read, write, close with like underscores or whatever are bad copies of Unix functions for portability. Don't even use those. Don't use any of that stuff. You're thinking about what you'd use on Linux. Oh, I mean, Linux has slightly different rules, and you can get bitten in a different way. So you can have a thing where the file data is on disk, but the inode in the directory is not updated. That used to be a problem that people had back in the day. I don't know if Linux does something to flush that specifically when you exec a program. I should hope so, because it's freaking stupid. But I don't know. It's like embarrassing. Like, I remember having to deal with that inode problem on Unix operating systems when I was in college, and it's just like, what? Excuse me? Okay. So okay, this is annoying. I don't know if I... The problem is, I want to know if the referrer is in the same compilation unit with the referee, or alternately, if the compilation unit changed since the guy was stored. Not that second one is not a very good question. The first one, the problem is everywhere I call get exported, I have to have a refer. We're going to butcher the code and put this in there. So we punt on these and then return a flattened then. We return that. So here we just say if same compilation unit asked referrer else okay. Now everywhere we frickin' call this, we don't do that for now. Owning statement blocks. I don't even know what that was for. I need to. But it's fine. Okay. Oh my God. Why are we doing hash table lookups here? Because it didn't used to be a hash table lookup, that's why. Like this should just be factored out. Okay, see. This one, I see this gets called from everywhere. So we would have to put a referrer here, which sucks. I'm not going to do that. This was my very early attempt at doing what I'm doing now. Honestly, this kind of sucks. Oh, I could do a cheap, shitty referrer thing. Oh my God, what a garbage. What a garbage this is. What a garbage. Okay, so how many more of these do we have? Oh my God, okay, 5 more. These ones are easy though. Literal null. Yeah, we should cache this pointer as well. This is like a special thing that we're doing. I don't want to explain it. All right. Same here. Okay. Get exported. What the hell is this? I don't even know. It's probably something that I put there that I don't remember. Okay. This is pretty good. Again, though, these numbers, they're not like breaking cleanly in anything that matters. Like, I'm not really seeing anything I can work with here, which honestly kind of sucks. So same versus other also mostly doesn't help. Like what we want is same because same is easily detectable. Actually, so we kind of punted and said these are other. What if I say that they're same really fast? Are we punting like a lot? Yeah, so that's a punt. That's probably a punt. Let's check 3 and 4 after I switch it back, because those are important. I could do it by line number. Mm, 3 and 4, they're a little more balanced actually, but not totally. So, I mean, I'm getting information about the system, but nothing that I know how to do anything with. I do think I want to know by line number, and this honestly super sucks because again, I have to go to all those call sites and put a thing, whereas in certain other programming languages this would be very easy. At least we'll clean up a couple of things in this file. So there'll be small victory. It's just I want one of these. I would love to take a byte out of this Boeing 757 number here. I just don't know how to do it yet. I'm going to make some tea, and then we're going to come back and do this by line number. Are there any questions about what I'm doing by people who've been watching enough to at least have the basic idea? No, hey, I just showed up. What is this? I'm 12 questions. No questions? I don't see questions. Nobody cares. Hash table goes burr. I mean, we want the hash table to go less burr, really. We want less burr on the hash table. I really thought we would see less of a split here. It's pretty weird to me. I would expect we would have seen a lot of sames and not very many others. No, it's not that there are too many entries and I don't know why. It's that I know exactly why there are as many entries as there are. I mean, I think so. The question is, how do we cut it down? And I thought it would be easier to cut it down. Well, I don't know if easier is the right word, but I thought it wouldn't be that hard to see a pattern as it actually is. Okay. Well, let's add the line number. So I want to know this is so weird. Okay, what can I do with line number? If I save the line number of where we get a hit, that might tell me if there are any of those things that don't produce hits. But I don't think that's actually very likely. I mean, I guess it would be useful to know that, but I want to go this thing here. So that at least cuts down one of these redundant call sites. Okay, let's look at WTF is this. Is primary exporter. What does that even mean? Is that a global? I don't remember doing this. Oh, yes, I do. Oh, yes, I do. Okay. Yes, okay. I know what this is. Okay. So we assert that something already was there. I kind of get the logic. Let me, before we get too much further on, let me just rerun that thing that I did to make sure it didn't break anything. Yes, you can compute what type something should be at compile time and use that to declare the variable. It's very easy. I've demoed it many times. Oh my goodness. It's not that hard. Okay. We don't appear to have broken anything. That's good news. So am I going ahead with my line number thing? I don't think so, because I don't... I mean, I guess that would tell me things like... Yeah, let's do it. Let's see if we get information. Oh no, we got to initialize this again. Unless there's some way to do that, and I don't know. I don't know. Okay, so plus plus. Okay, so get exported. Get exported. Oh, this literal null thing we got to do. Okay. So we're not printing that out yet. I just want to make sure it compiles. Max line number. We should raise that. Thought we were going to short a file. Okay. So when we print, all right. Wow. So they're all coming from line 769. I don't know if that tells me anything. Maybe it does. Like literally, one thing I could do is see if there's anything in here that's not represented. So 509 I know is in there. 513. 513 is not in there. Interesting. Okay. 603, 618, 620, right? Those are right there. Next one is 769. So 637 never fires. Where's the other one that I typed? All right. Uh, 769, 781. Oh, but that's, we shouldn't really count that one. 955, 1196, 1675. 1672. That's weird. What? We're going to get rid of that one anyway. But yeah, 1675. 1715. Not a thing. Okay. So we found a few that don't ever cause hits for this program. Whether that means it's impossible, I don't know. But that's fine for now, because that wouldn't help us that much. Let's see, what's line 769? Okay, duh. This is just the very common case where it's like, is something in a tree okay, I want to change what I'm looking at. We're using this referrer right now to know if we're in the same compilation unit. I want to actually know if it's a subset of referrers that can create hits. Yeah, there's like lots of ways to do this in this programming language, this type thing. There's a lot of ways. Now, as soon as I put like a version of, Godbolt or something up, then the same douche nozzle who wrote the thing about how ref term is really bad is going to go start using it and go, oh, this is so bad for all these reasons. Like, why should I bother? Seriously. Why should I bother? Okay, that's mean though. Maybe he didn't know better. Maybe he just didn't know better. Okay. So by referrer type, that's not necessarily going to tell me things. That's not necessarily going to be actionable, but if it appears fruitful, then I could store the line number when I put a dude in. That's a little bit annoying, but we could do it. Okay. We're going to say, we're going to get rid of the same versus different compilation units. And we're just going to say, same, we're going to reuse same and other without renaming them. All right. So this is by what node type is the hit, right? This is by who's referring to things. It does seem slightly more compact in terms of how many zeros, which is a good thing. Maybe. Most of our referrers are identifiers. Those clearly would be pointing at declarations. Not sure what else they would be pointing at. Number 7. What is number 7? Procedure call, okay. So procedure calls really do a lot of referring. Identifiers do a lot of referring. Yeah, so you see there's sort of this dual here where the biggest one in this column is identifiers. The biggest one in this column is declarations, and that's because identifiers tend to point at declarations. So that's no surprise. Honestly, there's just a lot more hits than I thought. I don't know. You're bad, you'll stop being mean. I meant my calling him a name was mean. You could say what you want. You could say what you want. Okay. I don't know what to do here. I am a little bit out of ideas for what to do right now. I mean, I could start doing some super dimension fortress analysis where it's like for every referrer, we look at a referee, we make like a node in the space of all connection types. Why are you asking about the hash function? What has that got to do with anything? Um, I kind of don't know what to do. Kind of don't know what to do. I could just add up real fast. Let's just see, because sometimes small numbers add up to a lot. But if we took all the ones with 0 hits and assume that that's correct, right? It's like 2,000, 4,000, 5,000. 13,000. 15. 19. And then we kind of start running out of gas. 20,000. So we could get rid of like about 20,000 out of 800,000. That's nothing. I mean, it's not nothing, but like it's not substantial. That said, though, most identifiers don't get hit. We could do things like, I'm going to want to think about this overnight, but okay, identifiers are a lot. Identifiers are 1/3 of the entries. And so okay, so most identifiers could probably be cut. right? 200,000. That is by itself not enough of a strategy to get this hash table much smaller. But if we could do that a few times, that would be good. Right, so what's 5? Binary operator. It's kind of samesies, like most binary operators. I'm a bit surprised that there's that many binary operators. How is that possible? How is that even possible? Do I believe that? Do I believe there are as many binary operators as declarations? 250, 350, 450. How does this add up to 700K? 250, 350, 450, 550, 650. Yeah, I guess. I don't know. I always get surprised by how much small numbers add up to. But I guess that's right. These are not collision counts. These are how much are we actually using the things that we put in the hash table, because we want to put less things. Hmm. $17? What is 17? Type instantiation. I kind of don't even know where those are coming from. I don't know. I'm out of ideas for now. I didn't think this would be this hard. There are other statistics I could gather that might make things clearer. So these numbers are just like total number of hits. But they're not number of unique hits. So kind of what I want to know is like, how many of these actually need to go in the table? And this is an upper bound on that. But it might be a very high upper bound even. Like, I don't know. Is there a reason why these numbers would be wrong? Yes, because they're program output. like here you can clearly see there's 100K of these put into the hash table, and we have 357K exports, or yeah, sharesies. That's not surprising. 25 is declaration, so this is like every identifier that refers to a declaration and whatnot. Don't know what to do here. Why don't I look at unique? Because that takes some work to do, and maybe not that much work, but a little bit. And the thing is, it still doesn't really tell me, because I need to then know how do I know which ones those are. Like, that's what I really want to know, is for these things in the left-hand column, I want to know, how do I know which things these are? Actually, no, let's count uniques, because the reason to do that, so we know how many nodes we're putting in the table. How many uniques we get tells us the minimum size of the table, right? That tells us if we did a good job of filtering everything magically, how low could we get it? And if that answer is not very low, then it's like, well, maybe we should do something about that. Maybe not. Got the last year and a half of uni left and really looking at getting a programming job. Since your uni pushed .NET hard, it seems .NET is from like 15 years ago. Do you mean like C# specifically, or do you mean just like .NET general? Like what kind of a school was this? Was it like a trade school, or was it in theory actually teaching you computer science? What are you supposed to do and learn though? Like, here's the thing, all this stuff like .NET or like Ruby beans or like whatever the hell, none of these things are actually important knowledge, right? Like, what you should be learning is how to do powerful things that most people can't do because they suck at programming, right? That's what you should be learning. As long as you learn that, well, A, what language or system you do that in is incidental because they're all Turing equivalent, right? But B, you'll also, once you start being able to actually do things, you'll start developing a taste for what systems you like and what you don't, because the ones that you like are probably the ones that help you actually do things, right? And the ones that you won't like are the things that get in your way needlessly and all that. want to do this with a hash table. I mean, that's really gross, but we could do it. It's in the spirit of what we're doing. Okay. So when we get a hit, okay. So down here, we're going to say that. Is it called items? It's called items. Dang it. Oh, we got to init it. Okay, that we don't totally love that number. That number is not bad. Like actually, if we cut this down to that, that's okay. But I was hoping this number would be more like, 20,000. Not super thrilled by how high that number is. It's like 1/6, yeah. 1/6 is not that good though. And that's our best possible result. So this was worth doing. Maybe what this means is we want to reduce the total amount of sharing in the frickin' tree. Because that's like, we in theory export every node in the program. So what we're saying is we've got like a DAG that revisits 1/6 of every node in the program. That seems like a lot. Seems like a lot. Semester with computer architecture where you only learned how to convert numbers to different number systems. This does not sound like a good school. I would encourage you to take your education into your own hands and somehow learn better things than this school is going to teach you. If that is an accurate description of the situation. How many of those nodes are trivial? What do you mean by trivial? Like, define trivial. Like I++, why is I++ trivial? If you delete that, people's program will break. Yeah, I'm not sure what to think about next. Is this memoization to avoid recompilation? No. No, 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 no. This is when we export data to your metaprogram, we both, well, you don't want to do like this weird deep copy that goes crazy and recopies things a million times, but you also, I mean, you want to be able to point people at an actual thing, right? Like, hey, here's where this identifier points to. You don't want to point at a copy of that thing. And it's not even a 6, it's a 5th. 20%. Wow, I'm tired now. My brain is tired. Had like a tension headache today and it was making me tired. Yeah, I mean, definitely you can learn a lot about programming on the internet. So like, if you're going to a school and they're honestly wasting your time, do something about that. Like, I realize most people won't when they hear that advice, but you don't want to waste that time. Yeah, I don't know what to do here. This is hard. I'm even surprised by this, honestly. I don't know what to make of that one. I could maybe I could take an approach where I break that down by refer type, but that wouldn't be much different than the data that we have. It might be a little different, but this sort of has to have most of that 449K in it. It might be time to end the stream for now. We had a very easy bug victory, but now we have a situation where it's not easy. I do not know where to go from here on this issue, except maybe to punt it until later. And generally, maybe think about trying to remove shared references from the exported tree if some of them seem unnecessary. But that still doesn't actually bias anything unless we can then lever that here, which I don't even know will be possible. And, you know, the biggest thing is identifiers, and we probably want those. So if we're saying we're not going to cut identifiers, then what, you know, what's the point? What is the point? Okay, I think I'm going to sign off for now. We'll probably do some game programming this weekend instead of compiler programming, because that'll be fun. Yeah. All right. Thank you, everybody. Short stream, but that is what it is. We wrangled with an issue. As it might just happen that I wake up tomorrow and I'm like, now I know what to look for, but I honestly don't right this second. So I'm going to be thinking about it in the background. Thanks, everybody. See you later.